Okay, today we are officially starting Unit 4, Quadratic Functions and Equations. So this whole unit is going to be focused on quadratics. And we're going to talk specifically about quadratic expressions and equations a little bit later. But today we're doing Lesson 1, and your learning objective or I can statement is I can factor out the GCF. So the first thing that we need to talk about is what does it mean to factor? What is factoring? Okay, so write down this vocabulary for me. Factoring means to rewrite an expression as the product of its factors. So if I have the expression 6, I can factor that by saying that is 2 times 3. So I factored 6 there, okay? A factor is just a quantity that goes into another quantity evenly. So 5, 10, 4, and 2 are all factors of 20. Okay, so that's what we're doing. We're breaking down the expression as far as we can. Okay, in lesson 0, we put things together. Okay, so factoring is taking those back apart. So what we're doing today is going to look like the opposite of what we did yesterday. Okay, you're often going to see the phrase factor completely. When you see factor this expression completely, it means break it apart as much as possible. And today we're going to do that by factoring out the GCF. So GCF stands for the greatest common factor. So if you break up a quantity or two quantities into their factors, then the largest thing that they have in common is the greatest common factor. And so we're going to look at GCFs of a few different types of quantities. First, we're going to look at GCFs of just numbers. So if I tell you to find the GCF of 5 and 10, well, 5, you can break it up to 1 times 5. All right. 10, you can do 1 times 10 or 2 times 5. So what's the largest number that they have in common? 5. So the GCF here would be 5. Okay? So you can also think of it as what's the largest number that goes into both evenly. So if I have 6 and 8, think about what is the largest number that goes into both evenly. It's 2. But if you weren't sure, you can list out the factors for 6 and 8. So for 6, we can do 1 times 6 or 2 times 3. For 8, we can do 1 times 8, 2 times 4. What's the largest number that they both have? It's a 2. Okay? So what about 12 and 20? What's the GCF of 12 and 20? The largest number that can go into both is 4. Okay? You're going to have to be able to do that. You're going to have to be able to pull out some common factors. Okay? We can also talk about numbers. I mean, not numbers, we just did that. We can also talk about variables. So if we have x squared and x to the 4th, we need to figure out how many x's they have in common. You can do this a couple different ways. So you can line up the x's. So x squared is x times x. X to the 4th is x times x times x times x. So you can write it all out. And how many pairs can you make? 1, 2. So that means the GCF of those is x squared. Right? Another helpful tip is that it's always the lowest exponent. So if you have 2 x's here and 4 here, the most that they could have in common is 2. So it's the one with the lowest exponent. Okay, we can say x to the 7th and x to the 5th. You can list out your x's. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. How many pairs can you make? 5. So the GCF is x to the 5th. Okay, you can also do that when you have multiple variables. So like x squared y and xy to the 8th. So first we can look at our x's. We have x squared and x. Which one's smaller or has fewer? X. And the y's, we have 1 and 8. 1 is smaller. So your GCF is XY. Okay, you can also have expressions where you have numbers and variables mixed together. So we might have 3x squared y cubed and 9xy to the fourth. So first you look at your numbers. We have 3 and 9. What's the biggest number that goes into 3 and 9 evenly? It's 3. Okay. We have x squared and x. The smallest is x. We have y cubed and y to the fourth. The smallest is y cubed. So that's the GCF. Another way you can figure this out if you're unsure is to just break it up. So 3 is 1 times 3. X squared is x times x. And y cubed is y times y times y. 9x to the fourth, so that can be 3 times 3 and 1x. And then we have 1, 2, 3, 4 y's. So what can we pair up? Here we have a pair of 3's. Here we have a pair of x's. And then we have 1, 2, 3 pairs of y's. Okay, so if you're ever in doubt, you can break it up, expand it all out, and then find your pairs. That's very similar to what we did when we were simplifying square roots. We had to write out factors and find pairs. Okay, that's what we're doing here. We are listing the factors and then finding pairs. Okay. Now, these are just small expressions. We're going to look at how to factor out the GCF of polynomials. So when there's more than one term. And we're going to follow the same principles here. They're just going to look a little bit different. Okay, so we're going to start simple. We have 3x plus 18. So this is like what we did before. We just have a plus sign in the middle. Okay, so we need to think. We have 3 and 18. What's the largest number that goes into 3 and 18? It's 3. So I'm going to bring that out front. Then we have an x here and an x there. Do they both have an x? No, so they can't have any x's in common. So 3 is the only thing that they share. All right, so we're going to bring that out front, but then we have to put the leftovers in parentheses. So if we have 3x and we divide out of 3, what's left over? X. If you have 18 and you divide out 3, what's 18 divided by 3? Positive 6. And that's your answer. So in front, we have our GCF, our greatest common factor, and in the parentheses, we have what's left over. Now, back in Algebra 1, if you had me a couple of years ago, you might remember me telling you a funny analogy. We talked about when you eat dinner, you eat what you want right now, and then you put the leftovers in a container to save for later. So that's what we're doing. The GCF is what we want to eat right now. We pull it out front. We're going to take it. All right? But then what we don't want, or what's left over, we put in a container, or in this case, parentheses. So what we want right now is our GCF, and then our leftovers go in the parentheses. Okay, let's look at another one. This one can be a little more complicated, and let me show you how to work it out if you're really unsure. We're going to list out all the factors and see what we have. So let me see. So for 12, I can make some different factors, but I think that I want to use 6. I know 6 is a pretty big number that goes into 12. So 2 times 6 times x times x. All right, and then 18x would be 3 times 6 times x. So what pairs can we make? I have a pair of 6's and a pair of x's. So I can bring 6x out front as my GCF, and what's left over? On top, I have a 2x, and on the bottom, I have a 3. So that's 2x plus 3. Okay, so if you can't see the factors in your head, you can't visualize that and see what you're pulling out and what's left over, you can always write it out and make some pairs. Okay, let's try another one. We have 49x squared minus 14x. So we have 49 and 14. What's a number that we know goes into 49 and 14? 7. So 49x squared is the same as 7 times x times x. And negative 14x is the same as negative 1 times 7 times 2 times x. So what can we pair up? We have a pair of 7s and a pair of x's. So I can put a 7x in front, and on the top I'm left with 7x. And on the bottom I have a negative 1 times 2, and that's just negative 2. Okay, another way to think about that is 49 divided by 7 is 7. If I have x squared, I take out one of the x's. How many do I have left? 1. Negative 14 divided by 7 is negative 2. If I have 1x and take it out, do I have any left over? No. Okay, now we're going to work through some examples, and I know this looks like a ton of examples, but the best way for you to see this and figure it out is just to practice it. So we're going to work through some examples. I do recommend that you write these down and try them on your own. Or if you don't feel like you can try them on your own, you can at least write them all down and write down the answers with me, and then you can look back at it when you do your work on Math Excel. But it will be helpful if you follow along with me, and the more we practice, the better you're going to be. Okay, and so I will try to go through these quickly so that this video isn't crazy long, but I also want to go slow enough so that you can understand what's happening. Okay, so number 4, we have negative x minus 3. So we have a negative 1 and a negative 3. The only thing that both of those have, the only factor that they have in common is a negative 1. So I'm going to pull a negative out front. If I have negative x and I divide out the negative, I'm just left with x. And if I have negative 3 divided by negative 1, that leaves me with a positive 3. Okay. Number 5, we have 6a minus 24. What's the biggest number that goes into 6 and 24 evenly? It's 6. Okay. Both of them do not have an a, so we can't pull one out. So 6a divided by 6 is just a. Negative 24 divided by 6 is negative 4. Okay, and you can always check your answers by doing the distributive property. So 6 times a is 6a, 6 times negative 4 is negative 24. All right, 12y squared plus 6. First, let's look at those numbers. What's the largest number that goes into 12 and 6 evenly? 6. Okay, only one of them has a y, so we have to leave that alone. 12 divided by 6 is 2. I didn't take out any of the y squared, so I leave it. 6 divided by 6 is 1. Okay, number 7, 42x squared minus 18x. Now, this one might be a little more difficult. It might be difficult for you to know the factors of 42, but you can think of the factors of 18 and see if any of those go into 42. So I know that 18 has 1, 2, 3, 6, 9, and 18. I know that 18 doesn't go into 42. I know that 9 doesn't go into 42, but 6 does. So I'm going to bring out a 6, and then I have x squared and x. So they both have an x. What's the smallest number of x's? 1. So we'll put that up front. 42 divided by 6 is 7. We have x squared, take out an x, we have 1 left. Negative 18 divided by 6 is negative 3. And if I have 1x and take out 1x, we don't have any left. Okay, and so what we're doing should look like we're undoing the distributive property. So we put things together in lesson 0, we're taking them apart now. All right, so number 8, we have 3 terms. So 4, 10, and 8. What's the biggest number that goes into all 3 of those? 2. We have 4 x's, 2 x's, and 1 x. They all have an x. What's the smallest number of x's? 1. So we'll pull that up front. 4 divided by 2 is 2. If I have 4 x's and take out 1, I have 3 left. Negative 10 divided by 2 is negative 5. If I have 2 x's and take out 1, I have 1 left. 8 divided by 2 is 4. And if I had 1 x but I took it out, I don't have any left. Okay, and this one you could also list out the different factors here and see how many pairs you could make. So for 4, I could do 2 times 2 and then 4 x's. For negative 10, I could do negative 1 times 2 times 5, and it's 2 x's. And then for 8x, I could do 2 times 4 and just 1 x. So there's a set of 2's and a set of x's. So we bring out a 2x, and on the top I have 2 and 3 x's. On the middle I have negative 1 times 5 times x, and on the bottom I'm just left with a 4. Okay, so if all else fails, list out the terms. All right, number 19. This one's a little bit different. We've got numbers, x's, and y's, but we're going to do the same thing. So we have 13 and 39. The GCF of 13 and 39 is 13. They both have an x. Here's 1 and here's 3. I can only pull out 1. Our y's, we have 4 and 3, so the smallest is 3, so I can take out y cubed. All right, 13 divided by 13 is 1. I had 1x and I took it away, so there are no x's. I had 4 y's and took out 3, so I just have 1 left. 39 divided by 13 is 3. I have 3 x's and took out 1, so I have 2 left. I had 3 y's and took out 3 y's, so there are no y's. So this one's just y plus 3x squared in parentheses. Okay, number 10. I have 10x to the 5th minus 25y to the 5th. So let's look at our numbers. What's the largest number that goes into 10 and 25? 5. And we have x's here and y's here. Are those the same? No. So I have to leave those alone. All right. 10 divided by 5 is 2. And I didn't take out any of the x's. Negative 25 divided by 5 is negative 5. And I didn't take out any y's, so I'll leave those where they're at. And that's kind of hard to read, so let me fix that for us. So we'll change it to y to the 5th and then close the parentheses. Okay. All right, we have just a few more. And again, I know that these look complex, and we're doing a lot of them, but the more you practice, the better you're going to get. Okay, number 11, we have 5, 25, and 10. What's the largest number that goes into all 3 of those? 5. Do they all have a y? No. So we can't take out a y. We've got to leave it. So 5y squared, divide out the 5. We have y squared. Negative 25 divided by 5 is negative 5. And we have to leave the y. And then 10 divided by 5 is 2. Okay. Number 12, we have 3x squared plus 5y plus 7. So 3, 5, and 7. All of those are prime numbers. The only common factor they have is 1. And then we have an x here, a y here, and then no variable on this one. So they don't have anything in common, so we can say not possible. It's not possible to factor out the GCF. Okay, and that happens sometimes. Now, 13 and 14 are more complex, and that's okay, and we won't see a ton of these later, but I do want you to be familiar with them just so you've seen them before. So number 13, we've got x squared, x cubed, and x to the 4th, but that's not really how the rest of them have been set up. The exponent should go biggest to smallest, so we're going to rewrite this. So 8x to the 4th minus 40x cubed plus 24x squared. Now, what number goes into 8, 40, and 24? 8. And we have 4x's, 3, and 2. So what's the smallest? 2. All right, let's divide and get our leftovers. 8 divided by 8 is 1. If you have x to the 4th and you take out x squared, you just have 2x's left. Negative 40 divided by 8 is negative 5. You have 3 x's, you take out 2, there's 1 left. And then we have 24 divided by 8, is 3. And we have x squared, we took out x squared, we don't have any left over. Okay. Number 14, we have 10x squared y cubed minus 18xy squared plus 8xy. So we have 10, 18, and 8. So what number goes into all of those evenly? Or the biggest number that goes into all of them evenly? At first I want to say 8, but 8 doesn't go into 10 or 18. If I think about 4 doesn't go into 10 or 18 either. I know 5 goes into 10, but not the others. 3 goes into 18, but not the others. They're all even, so 2. It looks like 2 is going to be my best bet there. And I have 2 different variables. I have x's and y's. So do all terms have an x? Yeah. And we have 2 here, 1 and 1. So what's the smallest? 1. All right, what about y's? I have 3, 2, and 1. The smallest is 1. So my greatest common factor is 2xy. All right, now let's do some division. 10 divided by 2 is 5. I had 2 x's and I took out 1, so I have 1 left. I had 3 y's, I took out 1, so I'm left with 2. Negative 18 divided by 2 is negative 9. I had 1 x and took it away. I had 2 y's and took out 1. And then 8 divided by 2 is 4. I had 1 x and took it out. I had 1 y and took it out, so that's just a 4. Okay, so there's all of our examples. You're doing the same process every single time. Look at the numbers and find the largest number that goes into both or all evenly. And then look at your variables and see how many of what kind of variable you have in common. And pull those out front, then do division to get the leftovers. Or, like we did up here, you can list out each of the terms in expanded form with all their factors, and then you can make some sets or pairs, and that'll help you figure out what needs to be pulled out front and what needs to be left over. Use these examples to do your homework in Math Excel. If you need any help or have any questions, please let me know. Hit the Ask My Instructor button, send me an email, or hop back in the Google Meet and let me explain it to you. Have a great rest of the day.